What if I told you that some animals can see ultraviolet light, others can detect heat, and some perceive colors we can't even imagine? Today we're diving deep into the bizarre ways animals see the world. My name is Bekruz Kambarov, and I invite you to journey with me into a realm that lies just beyond the veil of human perception. For us, the human primate, the world unfolds in a rich tapestry of color. But for our loyal companion, the dog, this vibrant spectrum is somewhat muted. Their world is painted primarily in shades of blue and yellow, with reds and greens appearing perhaps as indistinct grays or browns. Their visual acuity, while perfectly suited for detecting motion, especially at dusk and dawn, is not their primary window to understanding their surroundings. Indeed, while we navigate and interpret our environment largely through sight, the dog sees the world through an intricate and profoundly complex tapestry of scent. Their olfactory capabilities are nothing short of astonishing, estimated to be tens of thousands, perhaps even hundreds of thousands of times more sensitive than our own. Imagine walking into a room and not just seeing objects but smelling the history of who has been there, what they were doing, even perhaps their emotional state. This is the canine reality. For the dog, the nose is in many ways the true eye. Consider the humble bee, a creature synonymous with flowers and the sweetness of honey. We see a field of wildflowers, a riot of reds, yellows and blues, a beautiful if somewhat undifferentiated display. But the bee perceives something entirely different. Red, a color so vibrant to our eyes, is largely invisible to them. Instead, their visual world extends into the ultraviolet spectrum, a range of light completely hidden from human sight. To a bee, a flower is not merely a splash of color, it is often a glowing beacon, a meticulously designed landing pad. Imagine navigating a world shrouded in perpetual darkness, yet being able to see the warmth radiating from living beings. This is the remarkable reality for certain snakes, such as pit vipers, rattlesnakes, and boas. These reptiles possess an extraordinary sensory adaptation that allows them to perceive infrared radiation, essentially, the heat signatures emitted by other animals. This is not sight as we know it using reflected light, but a form of thermal imaging, a sixth sense that grants them a profound advantage, particularly as nocturnal hunters in environments where light is scarce. Even in the pitch black of a moonless night or deep within a darkened burrow, a pit viper can locate and strike its prey, often a small mammal or bird, with astonishing accuracy. If we thought our perception of color was rich, prepare to be humbled by the visual capabilities of the mantis shrimp. These remarkable crustaceans, inhabitants of tropical and subtropical marine environments, possess what many scientists consider to be the most complex eyes in the entire animal kingdom. They don't just see color, they perceive a kaleidoscope of hues and light properties that we can scarcely begin to imagine, let alone describe with our limited vocabulary for such phenomena. Humans as trichromats possess three types of color receptor cells or cone cells in our eyes, sensitive to red, green, and blue light. The mantis shrimp, however, boasts an astonishing 12 to 16 different types of photoreceptor cells. This doesn't simply mean they see more shades of the colors we see, it suggests they perceive entirely different dimensions of color, perhaps even distinct colors that have no equivalent in human experience. As twilight surrenders to the deep cloak of night, our human vision, so adept in daylight, becomes severely limited. But for the owl, this is when their world truly comes alive. These magnificent nocturnal predators soar through the darkness with a visual prowess that seems almost supernatural. Equipped with night vision so powerful, it's akin to flying with highly advanced, built-in optical technology, perfectly evolved for their silent hunt. An owl's eyes are not spherical like ours, but rather elongated tubes, fixed in their sockets, which means an owl must turn its entire head to look around, hence their famous ability to rotate their necks up to 270 degrees. These large eyes are packed with an incredibly high density of rod cells, the photoreceptors responsible for vision in low-light conditions. These rods are exquisitely sensitive, capable of detecting the faintest glimmers of light far beyond human capability, allowing them to gather every available photon from the nocturnal landscape. Dogs smell and color, bees see ultraviolet, snakes detect heat. The world we know is only our version of reality. To animals, it's a different universe. So the next time you look around, remember, there's always more than meets the eye.